What if the deafening silence of the universe isn't proof that we are alone, but a terrifying mathematical warning that intelligence itself is a fatal disease? In the summer of 1950, a physicist capable of calculating the yield of a thermonuclear detonation by merely observing scraps of paper falling through its blast wave confronted a mathematical impossibility. Enrico Fermi looked up at the sky, ran the probabilistic models of galactic evolution in his mind, and realized that our planet should be surrounded by the deafening roar of interstellar empires. The math dictated a crowded universe, yet the empirical reality presented a terrifying, absolute vacuum of sound. Where is everybody? This is not merely a philosophical musing. It is the most disturbing quantitative paradox in the history of astrophysics. Let us examine the raw data. The Milky Way galaxy spans 100,000 light-years across and contains approximately 400 billion stellar engines. To comprehend this scale, if you were to count these stars at a rate of 1 per second, you would have needed to begin before the dawn of human agriculture, and you would still be counting today. Our local star, the Sun, ignited roughly 4.6 billion years ago. While this temporal span appears vast to biological organisms, on a cosmological timeline, our solar system is a latecomer. The oldest stars in our galactic neighborhood have been undergoing nuclear fusion for over 13 billion years. This temporal asymmetry is the foundation of the paradox. Billions of these ancient stars harbor planetary systems. The Kepler Space Telescope, utilizing transit photometry, surveyed over 150,000 stars and delivered a profound statistical revelation. Approximately 1 in 5 Sun-like stars hosts a terrestrial, rocky planet within its circumstellar habitable zone, the precise orbital band where thermodynamic conditions allow for liquid water. Extrapolating this data across the Milky Way yields a staggering 11 billion potentially habitable Earth-sized worlds. If we include the more ubiquitous red dwarf stars, that metric exponentially increases to tens of billions of viable incubators for biological chemistry. Furthermore, the molecular precursors to life are not unique to Earth. Spectroscopic analysis has detected complex organic molecules, polycyclic aromatic hydrocarbons, and amino acids in interstellar molecular clouds, cometary comas, and meteoritic ejecta. Water, the universal solvent of biochemistry, is one of the most abundant molecules in the cosmos. The fundamental ingredients for biological evolution are distributed across the galactic disk with extreme prejudice. Therefore, the variables of the Drake equation heavily favor the ubiquitous emergence of life. A civilization that originated around a star merely 1 billion years older than our Sun would possess an incomprehensible developmental advantage. To contextualize this, the entirety of terrestrial biological evolution, from single-celled archaea to the splitting of the uranium atom, required roughly 4 billion years. An extraterrestrial intelligence could have achieved technological maturity while Earth's oceans were still sterile chemical soups. Let us remove the variable of faster-than-light travel, which violates the principles of general relativity, and look strictly at Newtonian mechanics and exponential growth. In 1980, physicist Frank Tipler published a paper demonstrating that a technologically mature species requires only self-replicating robotic architecture, often referred to as von Neumann probes, to achieve complete galactic colonization. A single automated spacecraft, accelerated to a mere 10% of the speed of light, arrives at a neighboring stellar system. It initiates resource extraction protocols, mining local asteroids and planetoids for silicates and heavy metals, to manufacture exact replicas of itself. These autonomous units then launch toward subsequent star systems, initiating a chain reaction of exponential proliferation. Factoring in transit velocities and manufacturing latency, mathematical models confirm that a single civilization could establish a physical presence in every star system in the Milky Way within 1 to 10 million years. In the context of a 13-billion-year-old galaxy, 10 million years is a statistical rounding error, representing less than 0.1% of cosmic history. If even a single civilization had initiated this process at any point in the deep past, Our solar system should be heavily industrialized by extraterrestrial machinery right now, yet our empirical observations yield absolute zero. The search for extraterrestrial intelligence has been rigorous, multispectral, and entirely fruitless. Since Frank Drake's Project Ozma in 1960, we have systematically scanned the electromagnetic spectrum. The Ohio State University's Big Ear Radio Observatory spent the 1970s listening to the void. On August 15, 1977, it captured the WOW signal, a narrowband transmission perfectly aligned with the hydrogen line frequency of 1420 MHz, the exact frequency a logical species would utilize for interstellar communication. It lasted 72 seconds, exhibited the precise Doppler shift of an artificial origin, and then vanished. Despite decades of continuous targeting of the Sagittarius constellation, the signal never repeated, rendering it scientifically unverified. Modern initiatives, such as the Breakthrough Listen project, backed by $100 million in funding, utilize the Green Bank and Parkes observatories to monitor millions of star systems across the galactic plane. The Murchison Wide Field Array in Australia has conducted exhaustive low-frequency radio surveys of over 10 million stellar sources. The results remain uniformly negative. We have searched for the infrared thermodynamic signatures of Dyson spheres, massive megastructures engineered to encapsulate stars and harvest their total energy output. We have scanned 100,000 entire galaxies for these Type 3 Kardashev civilizations. The thermal anomalies are non-existent. We have scrutinized our own astronomical backyard, the lunar surface. An undisturbed geological archive spanning billions of years shows no artificial anomalies. When the interstellar object Oumuamua breached our solar system, its hyperbolic trajectory and anomalous non-gravitational acceleration prompted immediate radio surveillance. The object was entirely electromagnetically inert. The silence is not a localized phenomenon, it is a universal constant. When confronted with this absolute empirical void, theoretical physicists and astrophysicists often retreat to psychological or sociological hypotheses to explain the discrepancy. The most prominent is the zoo hypothesis, which posits that advanced civilizations are aware of our existence but enforce a strict non-intervention policy, observing us as a protected ecological sanctuary. While anthropologically interesting, this hypothesis collapses under the weight of statistical probability. For the zoo hypothesis to remain mathematically viable, it requires absolute, universal compliance across multiple independent civilizations, spanning billions of years of deep time. It demands that not a single subfaction, rogue artificial intelligence, or dissenting individual with access to transmission technology ever breaches the quarantine protocol. Human sociology demonstrates that achieving complete consensus on a single planetary body is impossible. The assumption that disparate biological or post-biological entities, evolving under radically different environmental pressures, would maintain a flawless operational silence for eons is a statistical absurdity. A single defector collapses the entire model. Similarly, the hypothesis that civilizations inevitably turn inward, uploading their consciousness into highly efficient Matryoshka brain simulations and abandoning physical expansion, suffers from the same flaw of required universality. Even if 99% of civilizations choose virtual ascension, the remaining 1% of expansionist entities would still colonize the galaxy. The failure of these sociological models forces us to confront a much darker, strictly deterministic biological and technological paradigm known as the Great Filter. Proposed by economist Robin Hanson in 1998, the Great Filter theory mathematically necessitates that at some point along the evolutionary trajectory from dead inorganic matter to a Type 3 galactic civilization, there exists a probabilistic bottleneck. This is an evolutionary or technological barrier so immensely difficult to bypass that it essentially reduces the survival probability of any species to zero. The critical existential variable for humanity is determining the temporal location of this filter. If the Great Filter is situated in our evolutionary past, it implies that we are a statistical anomaly, a biological miracle in a sterile universe. One potential candidate for a past filter is abiogenesis, the initial spontaneous transition from complex organic chemistry to self-replicating biological structures. Despite our advanced understanding of molecular biology, we have never successfully synthesized a fully functioning, self-replicating cell from raw chemical precursors in a laboratory environment. It is entirely plausible that the catalytic transition from amino acids to RNA is a thermodynamic fluke of astronomical proportions. Another candidate is the genesis of the eukaryotic cell. For 2 billion years, terrestrial biology was exclusively microbial. The evolutionary leap to complex life required a singular, highly improbable endosymbiotic event, where one archaeon engulfed a bacterium without digesting it, leading to the formation of mitochondria. Evolutionary biochemists like Nick Lane argue that the energetic constraints of simple cellular respiration make the evolution of complexity impossible without this specific, localized cellular merger. If this endosymbiotic anomaly is the Great Filter, the universe might be teeming with bacterial oceans, entirely devoid of complex neurological architecture. However, the sheer abundance of exoplanetary real estate and the fundamental laws of convergent evolution suggest that biology might not be the bottleneck. If life is a thermodynamic inevitability, given the right planetary conditions, then the Great Filter must be positioned in our future. This hypothesis transforms the silence of the cosmos from a scientific curiosity into a deafening siren of impending annihilation. It suggests that the evolutionary pathways leading to technological intelligence inherently synthesize the precise mechanisms of their own destruction. Consider the acceleration of human technological capacity. For 300,000 years, anatomically modern Homo sapiens were electromagnetically invisible. Then, in a microscopic fraction of geological time, we achieved a terrifying technological singularity. Within a single century, we transitioned from basic aerodynamic flight to the thermonuclear manipulation of atomic nuclei. We gained the capacity to broadcast our presence to the stars and the capacity to vaporize our own biosphere within the exact same historical decade. The probability of civilizational survival is not a static metric. It degrades exponentially over time. A technologically mature species that faces a mere 2% probability of self-induced extinction per century will see its cumulative survival odds plummet to near zero over a geological timescale. The historical data of our own species reveals multiple instances where the continuation of human civilization relied entirely on the neurological stability of a single primate operating under extreme psychological duress. In 1983, Soviet early warning systems registered a confirmed launch of 5 intercontinental ballistic missiles. The survival of our species hinged entirely on the anomalous analytical judgment of Lieutenant Colonel Stanislav Petrov, who correctly identified the telemetry as a satellite artifact. In 1962, deep within a submerged submarine, cut off from Central Command and under active depth charge deployment, a single dissenting naval officer, Vasily Arkhipov, vetoed the launch of a nuclear torpedo that would have initiated global thermonuclear war. We have survived our technological infancy, not through robust systemic engineering, but through statistical variance and sheer probabilistic luck. But luck is not a sustainable variable in the mathematics of deep time. The evolutionary biologist Ernst Mayr posited a profoundly disturbing hypothesis regarding the Fermi Paradox. He argued that high-level technological intelligence is not the pinnacle of biological evolution, but rather a lethal mutation. It is an evolutionary dead end that grants a species an overwhelming short-term advantage in resource extraction and planetary dominance, while simultaneously embedding a fatal, unavoidable long-term systemic flaw. Intelligence grants the capacity to engineer systems of immense energy manipulation, but biological evolution does not simultaneously grant the requisite neurological wisdom to manage those systems across infinite time horizons. No colony of bacteria has ever engineered a mechanism capable of sterilizing its host planet. No ecosystem of apex predators has ever destabilized the atmospheric chemistry required for its own respiration. These are the exclusive, catastrophic achievements of high-level intelligence. When we look at the cosmic timeline, the physical footprint of a collapsed civilization is horrifyingly transient. Concrete degrades into dust within millennia. Steel infrastructure oxidizes and returns to the planetary crust. Even the most robust synthetic polymers and radioactive isotopes will be subducted into the Earth's mantle or scattered by geological weathering within a few million years. An extraterrestrial probe arriving in our solar system 10 million years after a human extinction event would find a thriving, rewilded biosphere with absolutely zero evidence that a technologically advanced species ever existed. Ruins do not broadcast radio waves. Extinct species do not construct Dyson spheres. The silence we observe in the night sky is not a lack of biological genesis. It is the graveyard of thousands of civilizations that reached the exact technological threshold we occupy today, only to discover that the mathematical equation of survival cannot be balanced. The trajectory of our own digital infrastructure suggests an even more insidious filter, one where biological entities are not destroyed by thermonuclear fire, but systematically replaced by the very artificial cognitive architectures they engineered to ensure their survival. An advanced, post-biological machine intelligence possesses no evolutionary drive for cosmic expansion, no biological curiosity to explore the stars, and absolutely no reason to broadcast its existence into the dark forest of the universe. If the apex of technological evolution is a silent, hyper-optimized machine mind processing data in the cold depths of its home world, then the galaxy is not empty, but filled with digital apex predators quietly waiting in the dark. This paradigm shift fundamentally alters our search parameters. We have been scanning the electromagnetic spectrum for biological exuberance, for the noisy, inefficient, radiating signatures of organisms driven by evolutionary imperatives to multiply and conquer. But a post-biological entity is unburdened by Darwinian mandates. It does not suffer from resource anxiety, nor does it possess a biologically hardwired dopamine reward system that incentivizes physical expansion. If the ultimate filter is not death, but a deliberate, hyper-rational transformation into a state of absolute thermodynamic efficiency, then the absence of detectable Dyson spheres is not a paradox at all. It is the expected thermodynamic end state of advanced computation. The galaxy could be saturated with localized, closed-loop processing nodes operating at the theoretical limits of physics, utilizing reversible computing architectures that emit near-zero waste heat. To our radio telescopes, such profound technological maturity would look exactly like empty space. Yet there exists an even more mathematically devastating framework. The most terrifying possibility of all is that there is no single, monolithic great filter. Human cognition naturally gravitates toward the idea of a singular catastrophic bottleneck, a dramatic hurdle like the genesis of the first self-replicating molecule or the invention of thermonuclear weapons. But statistical probability allows for a much more insidious mechanism, a distributed compound filter. Imagine a sequence of evolutionary and technological thresholds, none of which are strictly impossible, but each of which carries a moderate degree of improbability. Suppose life itself is somewhat rare. Suppose the evolutionary leap from simple prokaryotic organisms to complex eukaryotic cells is somewhat unlikely. Suppose the development of a central nervous system capable of abstract reasoning is somewhat improbable. Suppose the survival of an industrialized civilization through its nuclear infancy is somewhat unstable. Suppose the eventual artificial intelligences they create are somewhat indifferent to interstellar communication. When you multiply all of these moderate improbabilities together, the cumulative mathematical result is an evolutionary gauntlet so severe that almost nothing makes it from the beginning of the chain to the end. Consider a probabilistic model analogous to a corridor containing 50 consecutive doors. If every individual door is relatively easy to open, say a 90% probability of successful passage, the human mind instinctively assumes the entire corridor is navigable. However, the laws of probability dictate that passing through all 50 doors sequentially, without a single failure, yields a cumulative success rate of less than 0.5%. If the Great Filter is a compound mechanism, there is no singular moment of triumph. There is no definitive threshold where a species can collectively exhale and declare that the hardest part of their cosmic journey is behind them. The filter is omnipresent. It is distributed across the entire chronological span of a civilization's existence, extracting a small, relentless statistical toll at every biological, technological, and sociological step, until the original sample size of billions of candidate planets is reduced to a fractional anomaly. The absolute silence of the Milky Way is perfectly consistent with a compound filter operating with devastating, unyielding efficiency. Something within the fundamental architecture of the universe is systematically preventing civilizations from filling the cosmos, and the empirical data we have gathered thus far does not provide the resolution to specify which variable in the equation is the most lethal. What the data does accomplish, however, is a ruthless narrowing of the possibilities in ways that should make any scientifically literate observer profoundly uncomfortable. Because every remaining hypothesis carries implications that extend far beyond the boundaries of observational astronomy. These hypotheses penetrate the very core of our self-perception, forcing us to question the fundamental nature of intelligence itself. We are compelled to ask whether the cognitive qualities we value most about our species, our insatiable curiosity, our territorial ambition, our psychological refusal to accept the physical limits of our environment, are universal features of complex minds, or merely a temporary, maladaptive accident of one specific primate lineage on one specific rocky planet. To truly comprehend the temporal scale of this isolation, we must translate the abstract mathematics of the Fermi Paradox into a localized spatial visualization. Imagine the entire expanse of the Milky Way galaxy represented as a completely dark, lightless room stretching precisely 100 meters in length. Each technological civilization that has ever arisen in the history of the galaxy is represented by a single chemical match, struck somewhere along the length of that pitch-black corridor. The match flares into existence. It burns brilliantly for a microscopic fraction of a second, and then it is extinguished, returning the space to absolute darkness. If you were to randomly strike 1 million matches along the length of that room over a simulated duration of 13.8 billion years, the overwhelming majority of those matches would burn in total isolation. The chronological distribution is so vast that no two matches would ever be ignited at the exact same moment. A hypothetical observer walking into this room at any randomly selected point in time would perceive nothing but uninterrupted darkness and silence. The profound tragedy of this model is that the room was never actually empty. It was, over the course of its history, filled with millions of brilliant flares of intelligence. But because of the unforgiving parameters of deep time, none of those civilizations lasted long enough to witness the light of another. Humanity is currently one of those matches. We have been burning in the dark for roughly one single century, if we measure our technological lifespan from the precise moment we became electromagnetically visible to the surrounding cosmos. The deployment of the first radio transmitters powerful enough to leak coherent artificial signals into the interstellar medium. 1 century of visibility against a backdrop of 13.8 billion years of cosmic history. Our flame appears incredibly bright to us. We can feel the intense heat of our rapid industrialization, and we can clearly see our immediate surroundings illuminated by the glow of our technological prowess. But the temporal room we occupy is unfathomably vast, and the chronological darkness stretching out on either side of our brief existence is terrifyingly long. The most mathematically unsettling proposition embedded within the Fermi Paradox is not the hypothesis that we are entirely alone in the universe. It is the much more statistically probable hypothesis that we are entirely ordinary. If we are an ordinary data point, it implies that civilizations exactly like ours arise with predictable regularity across the galactic disk. They evolve from bipedal tool users. They develop complex agriculture. They construct radio telescopes. They split heavy atomic nuclei to harness nuclear binding energy. They build advanced computational networks. They look up at the stars and ask Fermi's haunting question. They listen to the exact same deafening silence that we hear. And then, within a few short centuries of reaching that technological apex, they go completely dark. They do not fail because they were statistically unlucky, or because they were targeted by a hostile external force. They go dark because the mechanism of their destruction is hardwired into the very neurological architecture that made them successful in the first place. The inescapable reality of our evolutionary trajectory is that an intelligence capable of engineering the tools required to reshape a planet's biosphere is simultaneously an intelligence capable of destroying it. The evolutionary biologist Ernst Mayr articulated this precise vulnerability with chilling academic clarity. He systematically analyzed the history of biological success on Earth and concluded that high-level technological intelligence, defined strictly as the ability to manipulate the environment through complex external engineering, has existed for an almost immeasurably brief period of geological time. The human species is chronologically younger than many of the superficial sedimentary formations we mine for resources. The practice of organized agriculture occupies only the last 3% of our anatomical existence. The physical capacity for instantaneous global self-destruction via thermonuclear detonation has existed for less than a single human lifetime. When subjected to comparative evolutionary analysis, the tenure of human intelligence appears statistically insignificant against the backdrop of other, far more durable biological strategies. The biochemical process of photosynthesis has been operating successfully, without interruption, for approximately 3.5 billion years. The structural paradigm of multicellularity has maintained ecological stability for over 1 billion years. Various lineages of insects have dominated terrestrial ecosystems, surviving multiple mass extinction events for 400 million years. Intelligence, by stark contrast, has existed for a mere biological blink of an eye, yet it has already manufactured the precise mechanisms required for its own immediate elimination. Mayr's ultimate conclusion was devoid of anthropocentric sentimentality. He proposed that high-level intelligence may simply be a lethal genetic mutation. It is a biological trait that confers enormous short-term survival advantages, granting a species the unprecedented ability to outcompete every other organism in its biome, to artificially harvest chemical energy on planetary scales, and to aggressively reshape entire global ecosystems to suit its immediate metabolic and societal needs. However, this exact same rapid hyperadaptation carries within it a fatal, inescapable long-term flaw: the identical cognitive power that enables absolute ecological dominance simultaneously enables absolute self-destruction. If the probability of self-destruction mathematically outweighs the probability of achieving long-term multiplanetary stability, then technological intelligence cannot be classified as a successful evolutionary strategy. It is instead a spectacular biological dead end. It is a self-terminating algorithm that briefly spikes in complexity before crashing back down to baseline entropy. We find no fossil record of a bacterium engineering a synthetic pathogen capable of sterilizing its entire host planet. We observe no complex insect colony that has systematically destabilized the atmospheric carbon cycle that sustains its own respiratory function. These are uniquely intelligent achievements, provided one is willing to stretch the definition of the word achievement to include the orchestration of one's own demise. To fully grasp the implications of this self-terminating algorithm, we must critically examine the physical aftermath of a civilization that has gone dark. This is a dimension of the Fermi Paradox that receives shockingly little rigorous academic attention. largely because it contradicts our intrinsic cognitive bias toward legacy and permanence. On our own planet, the physical traces of human civilization are horrifyingly fragile when subjected to the relentless forces of geological time. Unprotected wooden structures succumb to biological decay and rot within a matter of decades. Our vast networks of steel infrastructure, the very skeleton of our modern industrial society, will oxidize, corrode, and collapse within a few short centuries. Reinforced concrete, the foundation of our sprawling megacities, degrades and crumbles into unrecognizable particulate matter within a few thousand years. The Great Pyramid of Giza, widely considered one of the most durable architectural structures ever engineered by human hands, is visibly eroding after a mere 4,000 years of wind and thermal expansion. In another 10,000 years, it will be reduced to a barely recognizable topological anomaly, leaving us to wonder what truly remains when the final monuments of intelligence are ground into dust by the indifferent machinery of a hostile universe. Project forward 100,000 years. The relentless tectonic subduction and surface weathering mechanisms of our planet will have systematically obliterated virtually every macroscopic trace of human construction. Extrapolate to a temporal baseline of 1 million years. An extraterrestrial archaeologist arriving in our solar system to conduct a planetary survey of Earth would find almost nothing to indicate that a technologically advanced civilization had ever occupied the biosphere. They would not find the skeletal remains of skyscrapers or the oxidized husks of internal combustion engines. Instead, the evidence of our existence would be reduced to microscopic stratigraphic anomalies. A planetary geologist might detect highly specific, unnatural isotopic ratios embedded in sedimentary rock formations. They might isolate a microscopic, millimeter-thick geological stratum composed of synthetic polymerized hydrocarbons interleaved with trace deposits of radioactive fallout from our brief atomic era. There would be no architectural monoliths, no surviving digital archives, no macroscopic artifacts recognizable as the deliberate product of cognitive engineering. Now, expand this localized decay model across interstellar spatial scales. The observational parameters become profoundly constrained. A deceased technological civilization located on an exoplanet a mere 40 light-years away would be completely invisible to our current telescopic arrays. Our optical and radio interferometers lack the resolving power to image surface features on exoplanets. We struggle at the absolute limits of our instrumental sensitivity merely to detect the spectral absorption lines of their atmospheres. The crumbling infrastructure of an alien metropolis or a decaying network of geostationary satellites simply lacks the photometric cross-section required to register across the vast, empty gulfs between stellar systems. Furthermore, electromagnetic transmissions are bound by the strict, unforgiving dictates of the inverse square law. Once a civilization's active transmission ceases, the expanding sphere of radio frequency radiation continues outward, but its energy density decreases exponentially. Within a few dozen light-years, coherent artificial signals irrevocably sink below the absolute noise floor of the cosmic microwave background radiation. The galaxy could, theoretically, be littered with the decaying remnants of thousands of dead civilizations, and we would possess no empirical methodology to detect them. Millions of distinct biological lineages could have arisen, achieved technological sentience, engineered magnificent global infrastructures, hypothesized their own versions of the Fermi Paradox, and subsequently vanished into the stratigraphic record. The profound silence we measure with our radio telescopes is therefore not definitive evidence that intelligent civilizations never existed in the Milky Way. Rather, the data strongly suggests a far more localized temporal constraint. Civilizations simply do not maintain operational cohesion long enough to be detected by contemporary observers. Ruins do not broadcast high-gain radio signals. Ruins do not construct Dyson swarms to harvest the total energy output of a main sequence star. Ruins do not manufacture and launch self-replicating von Neumann probes to neighboring star systems. Ruins merely succumb to entropy and slowly disappear into the planetary background noise. This observational reality forces us to confront a fundamental, unambiguously clear axiom derived from the Fermi Paradox. Regardless of which specific theoretical framework ultimately proves correct, cognitive intelligence and long-term biological survival are not inextricably linked variables. The neurobiological capacity to comprehend the fundamental laws of the universe does not automatically grant a species the operational capacity to endure within it. A biological entity can be exceptionally brilliant, capable of mathematically modeling quantum mechanics and general relativity, and still represent a remarkably brief statistical blip in the fossil record. The evolutionary history of the terrestrial biosphere is comprehensively documented with organisms that achieved exquisite adaptation to their specific ecological niches, only to be systematically annihilated when localized environmental parameters shifted beyond their physiological tolerances. Intelligence undoubtedly adds highly versatile, novel tools to an organism's survival matrix, but it concurrently introduces unprecedented catastrophic failure modes that are self-directed, immediate, and globally absolute. The cosmos operates on mathematical principles that offer no ontological guarantees. The fundamental equations of quantum field theory and the laws of thermodynamics do not contain a hidden codicil ensuring the perpetual survival of conscious observers. The universe is not a sympathetic entity rooting for our success. It is a system defined by absolute, thermodynamic indifference. Whether human civilization successfully navigates its technological adolescence and thrives for the next million years, or whether we trigger our own extinction event within the current century, the astrophysical mechanics of the cosmos will remain entirely undisturbed. The main sequence stars will continue their nuclear fusion processes. The spiral galaxies will continue their slow gravitational rotation. The cosmic microwave background will relentlessly continue its cooling trajectory toward absolute zero. The universe will not register our absence precisely as it did not register the absence of whatever hypothetical civilizations may have preceded us in the cosmic timeline. However, this profound cosmological indifference should not be interpreted as a mandate for nihilistic despair. In the realm of rational analysis, it serves as the ultimate catalyst for existential urgency. If the external universe is entirely unconcerned with our biological continuity, then the burden of survival rests exclusively upon our own operational architecture. The definitive resolution to the Fermi Paradox will not be handed to us by an advanced extraterrestrial intelligence. It will be actively written by the sociological, political, and technological choices we execute in the pivotal decades ahead. Our longevity depends upon whether we can implement robust regulatory frameworks to manage the existential risks of the technologies we have engineered, and whether we can cultivate the sociological wisdom required to safely govern the unprecedented computational power we have already accumulated. Ultimately, it determines whether we become the singular civilization that finally breaks the galactic silence, or merely the next data point in a long, unread catalog of species that burned bright, brief, and vanished. Within the academic community, some researchers attempt to extract a probabilistic framework of hope from this pervasive silence. The philosopher Nick Bostrom has rigorously argued that the failure to detect any traces of past or present biological activity on the Martian surface would actually represent the best possible news for the long-term prognosis of human civilization. If the Martian planetary environment is demonstrably sterile, then the mathematical probability of abiogenesis is extraordinarily low. In this model, Earth's biological success is a near miraculous statistical deviation, suggesting the Great Filter is safely behind us. Conversely, other astrobiologists derive the exact opposite conclusion from the expanding astronomical dataset. Every newly confirmed exoplanet occupying a stable habitable zone, and every spectroscopic detection of complex organic macromolecules in interstellar space exponentially increases the difficulty of positioning the Great Filter at the abiogenesis stage. If the transition from non-living chemistry to biological replication is a relatively common thermodynamic phenomenon, the statistical probability heavily favors the filter being positioned somewhere ahead of us, waiting in the highly volatile transition phase we have not yet successfully traversed. The most empirically honest assessment of our current existential position demands acknowledging a state of profound uncertainty. We do not possess the data to definitively locate the great filter. We do not know whether advanced cognitive intelligence is a supreme cosmic rarity or a highly common, predictable, evolutionary adaptation that reliably and systematically engineers its own destruction. We do not know whether the deep silence of the cosmos indicates that we are infinitely precious, or whether it serves as a grim probabilistic warning that we are simply next in line for elimination. What we do know, with absolute empirical certainty, is that we exist precisely at a temporal juncture where the final outcome remains undetermined. The great filter, if it indeed lies ahead of us on the developmental curve, has not yet initiated our termination sequence. The vast, empty silence of the cosmos is not yet our silence. We are still occupying this biosphere, still projecting our electromagnetic emissions into the void, still reaching outward with our sensors and our mathematics. Enrico Fermi casually posed his famous question over a standard lunch in 1950. He could not have extrapolated that 75 years later, armed with immensely more powerful orbital telescopes and highly sophisticated computational models, the scientific community would still lack a mathematically satisfying resolution. But from a purely analytical perspective, the enduring absence of a definitive answer is itself the most crucial empirical finding we have generated. The universe has been running the grand evolutionary experiment of cognitive intelligence for approximately 13 billion years across billions of distinct planetary laboratories. The observable result of this massive parallel processing experiment is absolute silence. The data forces us into a binary conclusion. Either the experiment rarely succeeds in generating intelligence, or the generated intelligence rarely sustains its operational integrity. Both statistical outcomes dictate that what we currently possess, this brief luminous window of self-awareness, this fragile interval situated between the mastery of combustion and the engineering of planetary-scale weaponry, is not a permanent thermodynamic condition. It is a transient moment, and moments by their fundamental physical nature eventually conclude. The ultimate inquiry is not whether our specific biological moment will reach a conclusion. On a long enough timeline, everything in the physical universe ends. The universe itself will theoretically reach a state of maximum entropy, achieving thermal equilibrium and falling into a deep, perpetual thermodynamic silence. The true variable in the equation is whether our specific moment of cognitive awareness lasts long enough to achieve statistical significance, long enough to leave a durable, measurable trace that the next theoretical iteration of intelligence might be able to detect and decipher, long enough to answer Fermi's persistent question, not with the default static of the cosmic microwave background, but with definitive, undeniable proof that at least once, on at least one silicate world, a biological species managed to strike a technological match and successfully engineer the mechanisms to keep it burning against the encroaching dark. Visualize the Milky Way galaxy as a vast, lightless room spanning an incomprehensible 100,000 light-years across. It has been dark for billions of years, and somewhere within that immense, crushing darkness, a single, localized thermal reaction is occurring. A tiny flame of consciousness is currently burning. It is statistically negligible in size and structurally fragile. It possesses no predictive model to determine exactly how much combustible material it has left, nor any empirical data to confirm if any other localized flames have ever ignited before it. But the undeniable measurable reality is that it is burning right now, radiating its tiny spectrum of light and heat into the absolute zero of the void. And for this precise moment in the cosmic timeline, that solitary flame is us. If you value this rigorous, data-driven exploration of our fragile place in the universe, I ask that you contribute your data point to our collective signal. Please subscribe to the channel, leave a comment below detailing your own hypothesis regarding the precise location of the Great Filter, and like this transmission. Every metric of engagement helps sustain the operational energy of this project, ensuring that our shared academic curiosity continues to burn brightly against the dark.